Hello and welcome to the second of the series of videos aimed at developing retro games in vanilla JavaScript using the canvas element. My name is Anthony and please join me in my corner of the web where I like to build stuff for the browser in the latest technologies. Back in the early 90s, I was such a huge fan of Capcom's work. Street Fighter 2 and obviously Final Fight before it had a large impact on me as a child. They were the gold standard when it came to fighting games, and much of the one-on-one fighting games we have today are built on the fundamentals that this game cemented. Having such fond memories of these games, I thought I'd challenge myself to see if I could develop a section of this game myself and explore how the game ticked. And in doing so, I thought I'd create this tutorial series on the back of it to show how you too can develop your own fighting game. In recent years, when it comes to developing games for the browser, it usually means using the canvas element. And in this tutorial series, we'll hopefully get a little bit more familiar with that element and game programming in general. In this particular video though, we'll start off pretty basic for now by firstly setting up our project and then look to explore the canvas element itself. After watching the previous video, we should hopefully have all our tooling ready to go. The only other prerequisite for this tutorial is that you have some level of knowledge with front-end technologies, primarily with JavaScript and the use of browser's dev tools. As the tutorials progress however, we'll look to refactor our code and apply some common best practices, and eventually a solid build pipeline so we can create and publish a production bundle of our code and assets. So yeah, there's a lot to get on with, so let's jump straight in. So first things first, to get up and running we'll need to get our project created and set up, so obviously we'll need somewhere to store our files. So let's go create a folder somewhere on our machine. We'll do this from within my editor, just to keep it self-contained for the video. As we're using VS Code, I'll select the Files drop-down menu and select the Open Folder option. From here, I'll navigate to where I'd like to store the code project and create a new folder. I've got my own drive and folder here ready, so I'll just go ahead and create our own code folder and select that. The first file we'll need to create will be an HTML file. So let's go over to the Explorer window and click the New File button. We'll go ahead and name the file index.html for now, as this is generally seen as the standard entry point for most web hosts, and they'll look to serve this up by default. Next we'll add the necessary tags for a basic page, giving it a title and most importantly a canvas element inside the body. As we're using a minimal amount of CSS in this tutorial, there's no reason to create a separate CSS file. Instead, we'll just add a style tag in our head section to house our styles. As we'll eventually be requesting a large amount of asset files in our game, this will be one less request our server has to perform overall. We'll discuss performance much later in the video series, but at this point I guess every little bit helps. That said, if you feel more at home at keeping your CSS outside of your HTML, then by all means move it over to a separate file. So in regards to our styles, we'll initially add some basic styling for the page. We're setting the spacing inside both the body and HTML tags, and then adding a black background colour to the body. But now we'll also set the canvas background colour to yellow. Okay, and with that, let's see what we have so far. Let's bring up our browser of choice and open the HTML file. For reference, I'll be using Chrome and Firefox for this tutorial. So it seems everything is as expected. We have a yellow coloured canvas sitting in the top left hand corner of the web page, which also has a black background. You may be asking, why is the canvas so small? If so, let's open up the DevTools and inspect the element. You'll see it currently has a width of 300 pixels and a height of 150 pixels. This is the default size of the canvas element if we do not supply any overriding values ourselves. We won't override any sizing values in either the HTML or CSS, as we'll be controlling that in our code, which funnily enough we'll look to do next. Jumping back to our editor then, let's add our main JavaScript file. I'll again be using the default naming convention here and using index.js. And before we forget, we'll go ahead and add a reference to it in our HTML file. You may have noticed we've added it to the ed tag, along with the deferred attribute. This tells the browser only to run our JavaScript code once the browser has finished parsing the HTML, which will remove any initial race conditions with any other assets.
So we'll go ahead and assign our code entry point to the Windows onLoad event. This event prevents our code from running until the whole HTML page has finished loading any necessary resources, and as we'll be loading assets from within our HTML initially, this will ensure those assets are available before we attempt to use them. We'll add a console log just to ensure everything is working as it should. And yes, opening up the DevTools, it seems we're in a good place to continue. The first thing we'll want to do is get a reference to our canvas element. Let's go ahead and add a new variable and retrieve just that using the document's query selector function. With that done, however, we'll again update the console message to ensure we've got what we want, which all seems to be working well so far. Whereas the canvas element has no drawing functions itself, it does have various contexts which we can hook into. So let's add another variable and get the context we require. There are a number of contexts available such as WebGL, 3D and even VR, but most of them are out of scope for these videos. As we're wanting to build a 2D game, it makes sense that we opt in to use a 2D context. So we'll pass in the 2D parameter to get access to its specific drawing functions. And again, let's just log it out to ensure everything is good. While we're here, let's just have a quick look at the object itself. You'll notice we still have a reference to the canvas element, but we also have a number of other properties. Please have a quick look over these, as we'll be using some of them today, and some of the more advanced ones in the later tutorials. Generally though, they affect how certain drawing functions function. We should now probably move our focus to correcting the size of our canvas. For that, we'll need to know the dimensions of Street Fighter 2's original screen size. Let's pull up one of the sites I referenced in the previous video, the cutting room floor, as this has many stills from the original game. Navigating to the following page tells us that it was 384 pixels wide by 224 pixels in height. So let's apply that to our canvas. We'll set the width and height properties of the canvas element with those values. Returning back to the browser's DevTools, you'll see that the canvas now has the sizing set correctly, but unfortunately it's not made much difference to the physical area of the canvas itself. One small note here, we could have applied those dimensions directly to the HTML element, as shown in the DevTools window, but applying it to the code gives us more control, as you'll come to see. One way we could improve this is by applying a scale to the dimensions. So let's quickly go ahead and do that. As we're targeting 1080p, and hopefully you are too, we'll apply a 4x scale, which seems to fit nicely in those constraints, while maintaining a good zoom factor. While this has definitely solved our size problem, we've now lost our original dimensions, which will cause us problems with our drawing functions unless we scale them too. As you can guess, this could get complex very fast. Ideally, we want to keep the original size dimensions, but still scale the canvas. Okay, let's give it another try. Let's revert our previous change and apply it to the element style instead. Note that as we're using the style attribute, CSS units will apply, so we'll need to add px to our scale value. We'll use a string literal for clarity. Let's also move the hard-coded values to an object enum and replace the values for the same reason. Again, jumping back to the browser, everything looks perfect. We have our original dimensions and the canvas element has been scaled as expected. The takeaway here is that we now know that there is an actual difference between the scaling of the canvas style, i.e. its bounding box, versus using its actual width and height attributes, as shown within the DevTools window. Those attributes change the physical side of the canvas's image area, whereas the bounding box changes the dimensions on how it's drawn to our page. If that doesn't make any sense just yet, don't worry. This leads on to our third and final solution, but we'll come on to that a little later, as there's something we need to do before moving forward. Hopefully, like me, you're a little tired of pressing the refresh button every time you apply an update. Well, let's go ahead and install a handy VS Code extension to help remove that inconvenience. Opening the Extensions tab, we'll enter Live Server into the search box. This will give us a couple of options to choose from. Most people will select the top item by Ritwick Day. Hopefully I've pronounced that name correctly. And with 21 million downloads and a 4.5 star rating, I couldn't fault you. However, I actually prefer the 5 server version of the extension, which has a few more features. Ultimately though, both of these extensions launch a Node.js dev server in the background and provides an easy no-config way to host and serve your web project assets. I'll let you dig a little deeper into its features, but for now it has hot reloading as standard, which is what will cure our manual refresh issue. Regardless of which extension you choose, and as with every extension, clicking the install button will add it to VS Code. If necessary, follow any on-screen prompts. The result will give us a Go Live button in the status bar at the bottom of the screen. Clicking this will toggle the launching and stopping of the server. So from now on, let's keep it turned on, and in our browser, let's navigate to the local host address that it provides. As you can see, there is no visible difference, which is actually a good thing. If you're not aware of what hot reloading is, basically, the server will watch your project files, and if we make any changes to them, we'll automatically notify the browser and send the latest version. Fancy stuff indeed, and definitely helps to keep front-end developers in a much happier place. Okay, with that, let's get back to the code and have a look at what the drawing functions our canvas content actually provides. We'll start by drawing a line from the top left-hand corner to the bottom right-hand corner. Not overly exciting, I agree, but this will let me explain the coordinate system of the context. The context origin point is at the top left-hand corner, so this will have an x and y axis position of 0, 0. The coordinates go down and right across the canvas image, ending at the width and height attribute values we specified earlier. In our case, this is 384 by 224. Just for clarity, the middle of the canvas would be 192 by 112, which is a division of 2 on each axis. So with that in mind, let's go and draw the canvas and prove this. To draw a line, or any shape for that matter, on the canvas, we'll first need to tell it which styles we'd want to use for its drawing functions. Using our context variable, we'll first set its stroke style that will be used by the line we're about to draw. This context property is very similar to the standard CSS color property and takes most of its values. We'll explicitly set it to black so we can change it later. Next, we'll set our stroke starting position at the context origin point at 0, 0. We'll then tell it to draw a line to the bottom right hand corner using our enum object values we created earlier. These commands alone will not do anything, as the canvas context works on a batching system, so we can queue up as many of these commands before telling it to draw them. To do this with the line, we'll use the stroke function. With that, we finally have something visible on our canvas. So returning to our browser, yep, you guessed it, we have a thrilling black line across our screen. Okay, let's now do the same but in the opposite direction. We'll add another set of move to and lie to calls above the stroke function, to draw from the top right hand corner to the bottom left. We'll also change the stroke style colour to yellow, and in our HTML code we'll change the canvas background colour in the CSS to black. Go ahead and save the changes and head back into the browser to see the results. And you probably guessed it, we have a yellow cross covering the entire canvas area. You probably noticed that our canvas is currently overflowing the browser window at the moment, and yes, this is troubling me too. We could change the scale in our game viewport enum, but we'd still have a fixed canvas size, and as you can see, we'd probably not cover the screen correctly either. Ideally, we'd want the canvas to resize with the correct aspect ratio of the available space. If you remember, I mentioned we had a third solution for resizing the canvas. Let's go ahead and implement that. Surprisingly, it's actually now very easy to pull off using CSS, without having to resort to something like event listeners. Head back into the code and remove our previous scaling solution, using the style property. Then in the CSS, we'll add a couple of styles to enable the canvas to size correctly. The eagle-eyed of you will notice the use of the new object fit property. This is where the actual magic happens. As the canvas is basically just an image to the browser, we are able to use this property to contain its size within its parent, keeping its aspect ratio. Simple, huh? We'll also combine the body and canvas background colour just for completeness too. Now viewing the canvas in the browser, you can see the canvas magically adjusts correctly, no matter the size of the browser window. And yes, we've even preserved our canvas area dimensions too. Nice. So, there's one last thing that's still bothering me, and that's our pixels. And as we're using a low resolution for our base dimensions, you may notice the canvas has a blurry thing going on. And I personally like my pixels to be big and chunky, especially for retro games. If you can't see it, especially under YouTube's compression, let us go ahead and shrink our game viewport dimensions somewhat. I'll add a divide by 3 and have another look. The canvas dimensions are now roughly 128 by 75 pixels, and it's now very obvious, hopefully. Now, this is purely a personal and cosmetic thing, I agree, but if you're like me, you'll want to fix this too. Thankfully, it's another easy CCS win. However, it's annoyingly implemented slightly different in different browsers, at least for now. The property in question is image rendering, and it has a number of supported algorithms for how we'd want certain images to be rendered to the browser, for lead off. In our CCS, let's go and add this property under the canvas selector. Depending on your browser, its value should either be crisp edges or pixelated. So we'll add them both, with pixelated being last. The reason we have used both properties is due to the fact that both algorithms are still yet to be agreed upon and finalised, even though they've both been supported since before 2014. Welcome to the world of web development, I guess. And finally, we now see our yellow cross in all its pixelated glory, just like we wanted it. So let's also remove our game viewport division, so that we're back to the original dimensions we had before. So with that, I think we've now finished setting up our canvas. So it's time to move on to the fun stuff, images. But before we do, we'll need to source an image that we'll want to use. Let's visit another site I mentioned in the previous video, the Spriters resource. Navigate to the arcade section, and then to the Street Fighter 2 page using the alphabetic sub-pages. I'm going to use the Ken sprite in this example, but by all means, you can pick any of the characters available. While we're here, let's thank the following guys for spending the time and ripping these sprites. You may want to download a copy of the image for later use, but I'm just going to copy the image for now and paste it into my drawing tool of choice, GraphicScale. We only need one frame initially for this example, so from here I'm going to pick the selection tool and draw a box around one of the sprites. We'll crop to this frame, removing the others. Let's save this as a web-friendly image to our project folder. For reference, I'm going to use PNG and then call the file something original like ken.png. Regardless of the sprite and character you chose, you should now be able to see the PNG file from within VS Code. We'll now need to tell the browser to load this image so that we're able to reference it in the canvas's context. The easiest way to do this is to add an image or an img tag into our HTML, where the browser will naturally load it when it passes the HTML. However, the browser will also naturally think the image should be displayed and visible on the page. But to prevent that, let's add a little CCS so that any img tags are not rendered in the DOM by default. Moving back over to our JavaScript code, let's go ahead and grab a reference to this image element. So just like before, let's add a query selector to do this, just above our context code. Now we need to welcome the most important context drawing function you'll use, especially in 2D games, and that is the drawImage function. This special function allows you to take either a whole image, or a section of it, and draw it to the context, at a set position. In its simplest form, it takes 3 parameters. Firstly, it'll need a reference to the image data, then it requires a specific X and Y position where you'd wish to draw it in the available context dimensions. In this instance, we're using our Ken image and drawing it at the origin point at 0, 0. And that's all there is to it. Checking our browser shows that our Ken image is now drawn in the top left hand corner. The only snag here is that we're unfortunately also drawing the blue background that came with the original image, which we'll never do. This is where transparency comes into play. Whereas each pixel in the image can have a value of fully on or fully off, it can also have a value of anywhere in between, producing a level of alpha or opacity. We'll leave that for another day however, because for our Ken here, we just need to set all the blue pixels to fully transparent, or off. Fortunately, most graphics tools make this a breeze. In GraphicScale for example, it's just a matter of setting an individual colour to transparent, and then resaving the image. Most other sprite tools should work very similar. Although in some of the bigger painting tools, you may need to apply a mask and remove the pixels manually. Either way, check it back in the browser, you'll see now that the blue background is no more, and the yellow cross can be seen clearly behind Ken. Until now, we've only been drawing in one pass to the context, and at the end of that pass, nothing more happens. And honestly, this might actually be what you'd want if all you wanted was a static image on your web page. But as we're attempting to build a game, we'll obviously need to draw much more of these drawing passes. In relation to games, or just animation in general, these drawing passes are usually called frames. You've all probably heard the phrase frames per second, or its abbreviation FPS. Well, that's basically what we've just done. We've drawn a single frame to the canvas. We will therefore need to introduce a form of game loop to continuously draw multiple iterations of these frames, which in essence creates motion, or rather animation. There are obviously multiple ways to produce loops within JavaScript, but we need a way that ensures we don't lock up the browser tab or consume unnecessary system resources. We also need it to be consistent and for it to run smoothly as possible. Luckily for us, JavaScript provides its own method to do just that with the requestAnimationFrame function. This function tells the browser to safely request a new frame of animation on the next repaint. By default, the browser will attempt to sync this repaint with your display's refresh rate. As you can see from the example here, the requestAnimationFrame accepts a callback function as an argument, and this is where we pass in our frame or main game logic function. So with this knowledge, let's go amend our code and create our own animation callback loop. Let's first wrap our drawing code within a function. We'll call it frame for now, to make it obvious that this code is to be executed on each repaint frame. We will then add the initial requestAnimationFrame at the bottom and pass in our frame function reference in as a callback. This will be our first call to initialize the start of the animation. Lastly, we just need another requestAnimationFrame call from within our frame function to therefore produce the actual animation callback loop. If we were to go back into the browser, you'd obviously see no difference, as there's no physical changes between each frame at the moment. But we do indeed have our main loop up and running. Let's quickly prove this. Open up the DevTools and click on the Performance tab, and then click the Record button on the top left hand corner. You'll only need a few seconds of data, so click Stop shortly after. If you've never used the Performance tab before, this is where we can collect audit and debugging information about the currently running browser tab. For this tutorial, however, we're only interested in the frame information. As I hover over the collected frames, you'll see that it's hitting a constant 160 frames per second, which is the actual refresh rate of my display. You should ideally be seeing a similar value matching your own display's refresh rate here. We'll talk more about frame timing in the next video, but for now, this is exactly what we wanted and confirms we're running at a smooth and stable frame rate, and that the canvas is able to sync correctly to our display. If you're seeing frame drops, it could be that your machine or your browser isn't able to keep up with your display. Okay, I think we're ready to start performing some of that animation motion we've been talking about. How about we go about moving Ken within our canvas? First, we'll need to provide a couple of variables to store his position on the canvas. I'll set up a position object, which will house the X and Y canvas coordinate properties. Next, we'll update the drawImage call with these position variables. Let's now add a line to increase the X position on each frame so that Ken eventually moves across the screen. So, looks like we have a couple of issues here. Ken is indeed moving across the screen, but he seems to be leaving a trail behind him. To be honest, this is as expected, as with each new frame we're literally drawing on top of the previous one, which unfortunately produces this possibly unwanted side effect. You might have noticed some evidence of this from the yellow cross, as it's now being drawn over Ken's trail in the following frames. Normally though, we'd want to clear the previous frame before drawing the new one. Fortunately, this can be easily rectified by introducing a context function called clearRect to our frame loop. As you can probably gather from the name, this function clears a rectangle at a specified set of coordinates. The coordinates are composed of 4 arguments: the X and Y positions where you'd want to start drawing, and the width and height dimensions that define the overall size of the rectangle. We'll make sure to add it before any of our other drawing calls to ensure it's the first thing the frame draws. We'll use the viewport object to clear the entire canvas area. This effectively clears any previous content the canvas may have had from the previous frame. Checking back in the browser, we can see that Ken has vanished. This is because we've not got any constraints on his X position, and therefore he's moving further than the width of our canvas. Refreshing the browser tab will reset the animation, and we can clearly see Ken move slowly to the right and off the side of the screen. Let's look to add some quick code to contain its movement. We'll add a new variable called velocity to hold the speed on which Ken can move. We'll also replace the hard-coded value for the X movement. Next, we'll add a quick conditional check to see if the X position is either higher than the width of our viewport or less than 0. These values being the furthest left and right sides of our canvas. Either way, we'll reverse the velocity of the X position if it hits these constraints. And it all looks good, but with one minor flaw. You'll notice Ken sugs off the screen somewhat. This is because Ken's current origin point is at the top left hand corner of his image, and the conditional check doesn't currently cater for the image width. We'll talk about image origin points in a later video, but for now, let's amend the logic to take into account the width too. Probably the easiest way to do this is to use Ken's image object, as this provides the image dimensions by default. So let us subtract the width value from our viewport width and check again. And finally, Ken is now contained within the canvas area. So yes, I'm at the point in the video where I'm getting a little bit bored of our black background. Maybe it's the time we look for a more suitable temporary alternative. Searching the web, I stumbled upon another great homage site called the Street Fighter 2 Sprites Wiki. This community site contains a whole host of valuable information on the series of games, but primarily for us, the site has a number of background images available for all character stages that are in the correct size for our canvas area. So a big shout out to whoever provided those images, as unfortunately I was unable to find any names on the site. Navigating to the games menu and then onto the World Warrior page, we should be able to see multiple tabs for various details relating to the original game. As a side note, I was really impressed by the amount of information available on this site, all collected by its maintainers. I'm sure some of this information will become useful for later videos in the series, but for now we'll continue on and click the Stage tab. From here I'll jump onto my character of choice, Ken, and download a copy of Ken's background. Although depending on the character you chose originally, you might want to pick one of the others. Either way, save the file into your project folder with a creative name, something like background.png. Once you have the file in your project folder, head back into our HTML code and we'll replicate the same process as before, starting with adding an img tag to the body that references our new background image. Once done, in the JavaScript file, we'll amend our original query selector line and use the query selector all function instead. If you're not aware, this returns an array of all the matching elements rather than just the first, in the order that they appear in the HTML file. This will therefore allow us to use array destructuring to create both our Ken and background variables. As the background image will completely cover our canvas area, we'll no longer require our clearRect call, as the image itself will now naturally clear any previous drawing calls. So we'll comment out that line and in its place add another draw image call, but this time for our background. The background will be stationary for now, so we'll just use 00 for the position. Although in later videos we'll discuss this more and go into using a camera for producing parallel scrolling. Oh, and while we're here, I've completely forgotten about our lonely console log for some reason. So let's quickly comment that out too, just for good measure. Again, checking the results in the browser, it all looks good. But for the final part of this video, let's go ahead and clean it up a little. We'll move Ken and give him a more appropriate position, so that he's now on the floor rather than floating in mid-air. We'll also wave goodbye to our yellow cross and comment that out too. And with one more final check in the browser, our code is beginning to look more like an actual Street Fighter game. And with that, I think it's a perfect place to end the second part of this tutorial. So what have we achieved so far? Well, we've set up our project game folder, we now know what the canvas element can do and how to size it, we're able to load images from within the HTML. We've also used a number of the canvas drawing functions, primarily the ones for images. We've also learned what's the best way to produce an animation or gameplay loop within the browser. Overall though, hopefully you've learnt some good foundations for any canvas-based game development. Please let me know what you think, especially if you found this tutorial helpful so far. This is my first time doing something like this and I'm still getting to grips with the tools and my style. But yes, I'm sure you've noticed that already. I'm hoping to have the next video out in a couple of weeks, and this will focus on a number of things, primarily refactoring the code into classes and using ES modules to allow us to keep our code more readable and easier to maintain. we'll also take a look at sprite sheets and what they actually are. This will lead into understanding character animation and how to fully utilise the draw image function to see how truly useful it actually is, which in turn will give Ken more frames of animation and movement. And finally, we'll also dig a little deeper into frame timing and how that benefits us, especially in a game like Street Fighter. So hopefully you'll join me for that, but while you wait, why not experiment with the current code and maybe extend it? Add another character for example, and then see if you can get them to move across the screen in a different direction, possibly on the y-axis? Either way, thanks again for watching and getting this far. It's really appreciated. Again, please let me know what you think in the comments. I'll speak soon, and out.